In this problem, we want to find equations of the tangent line at the two given points. So we got y plus 1 squared is equal to 4 times x minus 3 squared at the points 3, 5, and negative 5, 1. Well, our first step is to find our derivative. So we'll use implicit differentiation. We'll take derivative of everything where it's sitting. So we're going to take the derivative of the y plus 1 squared with respect to x. We'll take the derivative of the 4 times x minus 3 squared with respect to x. I guess that's it. Okay. These are both the chain rule, the general power rule specifically. We got parentheses to a power. So you take your power, put it out in front. What's inside the parentheses remains as is. Lower your power by 1, and then you multiply it times the derivative of what's inside the parentheses with respect to x. Same thing over here. 4 stays out in front. Take your power, put it out in front. What's inside the parentheses remains as is. Lower your power by 1, and then you multiply it times the derivative of what's inside the parentheses with respect to x. So we got 2 times y plus 1. The derivative of y plus 1 is 1, but then we have to add on our y prime. Remember, if you're taking the derivative with respect to x and it's really y, you have to add on the y prime. 4 times 2 is 8 times x minus 3, and derivative of x minus 3 is 1. So that 1 disappears. 2 times y prime is 2y prime. Y plus 1 equals 8 times x minus 3. Now normally we would get rid of parentheses, but actually this is already in perfect form. To get y prime by itself, we just need to divide both sides by 2 and y plus 1. So we'll divide both sides by those, 2 and y plus 1. And we got to do the same thing over here. The 2's would cancel, the y plus 1's will cancel. And we get y prime. 8 divided by 2 is 4, so we got 4 times x minus 3 over 2 times y plus 1. Step 2. We'll have 2 parts here. Or 2 separate problems, I should say. Wanting to find the equation of the tangent line at these 2 points. So I'm going to change my y prime to m, and then I'll plug in the point for x and y. So put that in for x, put that in for y. I'll do the same thing here. I'll put that in for x, I'll put that in for y. So I got 4, and so 3 minus 3. This one looks like it's going to be pretty easy. And then here, I'll have 2 times y, which is 5, plus 1. Excuse me. Well, 3 minus 3 is 0. 0 times 4 is 0. 0 divided by anything is 0. So you get m is equal to 0. Now, the reason why I said this one's easy for step 3 and step 4, if you got m is equal to 0, that's a horizontal line. And if it passes through this point, and it's a horizontal line, then that's going to be y is equal to 3. Wait a minute. Y is equal to 5. I better go back to bed. Again, m is equal to 0, we know is a horizontal line, and it's going to be of the form y equals a number, and it'll be whatever the y part of your point is. Now this one. This one we have to do a little bit of work on. Okay, so we'll plug this in for x, plug this in for y. So I got 4 times negative 5 minus 3 over where'd that 2 come from? Boy, I'm not doing too well here, am I? There. That 2 shouldn't be there. Okay. Y plus 1. So we're going to have 1 plus 1. So that gives us 4 times negative 8 over 2. 4 divided by 2 is 2, times that gives us negative 16. Now let me double check myself here since I made that screw up. 8 divided by 2 is 4. Can't do basic math. What's that? Worked hard all day. I did work hard yesterday, but I'm probably just going senile, so I'm not getting it quite right now. Okay, that looks right then. Okay, step 3. We want to plug in the given point for x and y. We said y was 1. M we just said was negative 16, and x is negative 5 plus b. Well, that gives us negative times a negative is positive, and this gives us something, 80 plus b. And take it over to the left side. We got 1 minus 80 is equal to b, or b is equal to 79, or negative 79. I have to quit watching TV. They're advertising one of my favorite shows coming on tonight, so I was distracted. Okay, we'll plug in negative 16 for M, and plug in negative 79 for B, and that would be our our equation of the tangent line. Let me just double check real quick. Okay, the points look good there. So we had to get in and screw this up. That looks fine. So those would be our answers.